In this video, I will talk about horizontal asymptote and limit at infinity. Now, let's talk about what horizontal asymptote mean in general. Now, it has a Cartesian plan, that's the y-axis and the x-axis, has the horizontal asymptote at y equals to L. Now, a function may look like this. It is approaching the number L, but it never gets to L. And we need to take it to the infinity in the x direction. It's getting closer and closer to L, but it never gets to L. Or a function may come this way. Right? It is getting closer and closer to the letter L, or the number L, but it never gets to L. And that is the positive x direction, right? So it's a positive, it's getting to the positive infinity. Okay, similarly, a function may go this way. And this way is the negative x direction. It's getting closer and closer to L, but it never gets to L. And this time we have to take it to the negative infinity in the x direction. Or the function may look like this, may come this way too, right? It's getting closer and closer to L, but it never gets to L. So this is the horizontal asymptote. Okay, now we can summarize it like this. There is a horizontal asymptote y equals to L for the function f at x if either limit as x approach positive infinity f at x equals to L, or limit as x approach negative infinity f at x equals to L. Okay, so either one will work. And of course, y is the function of f at x. Okay, so this situation here models this scenario here. And this situation here models this scenario here. Okay, now let's talk about the rule for horizontal asymptote. Now let's say you have a function f at x equals to a function in the numerator divided by another function in the denominator. Like this. And, right? N here is the highest degree of power in the numerator, and M here is the highest degree of power in the denominator. And we know that if N is less than M, the horizontal asymptote will be y equals to 0. And if N is equal to M, the horizontal asymptote will be y equals to the leading coefficient in the numerator divided by the leading coefficient in the denominator, which is a over b. Now, if n is greater than m, there's no horizontal asymptote. Okay, so that's a rule for horizontal asymptote. Now, doesn't matter which way we use, right? Whether it's the limit or this rule, we should get the same answer for the horizontal asymptote. So let's try out some examples here. Now, example number 1, right? Now let's say f of x is equal to 1 over x squared minus 5. Now, let's use the rule here. This function here can be seen as f of x equals to, now 1 is also the same as x to the power of 0. Divide by x squared minus 5. Now, since the highest degree of power in the numerator is 0, which is less than the highest degree of power in the denominator, which is this situation here, right? The first situation. Then the horizontal asymptote should be y equals 0. Okay, now let's use the limit method. By taking limit as x approach positive infinity, right? We use positive infinity on both sides. Now, since the rule is this, right? Either one of these works, it will work. So let's use the positive infinity instead, okay? So we will take limit as x approach positive infinity on both sides of the function. So on both sides of the function. Okay. Here, limit as x approach positive infinity, f of x equals to limit as x approach positive infinity, here, 1 over x squared minus 5. Okay, now you can directly plug in infinity into x here. So the left side will stay the same. And the right side is 1 over, that would be infinity squared minus 5. Now, infinity squared is a really, really large number. So 1 over a very, very large number is close to 0. So I would say that limit as x approach infinity, f of x is equal to 0. Now, this form is the same as this form here. That means L is equal to 0 in example 1. Right? And that's the horizontal asymptote. Y equals 0. And that answer is the same as this answer here, right? So either way, I will get the same answer. Okay, let's look at example number 2. Let's say f of x is equal to x squared minus 2 divided by x squared plus 2. Now, let's use the rule. The highest degree of power in the numerator is 2, which is the same as the highest degree of power in the denominator. And that is this situation here. This situation here, right? Then the horizontal asymptote will be the leading coefficient divided by the leading coefficient, a over b, right? And in this case, the leading coefficient here is 1 and 1, so it's 1 over 1. So the horizontal asymptote is y equals to 1. Now y equals to 1 over 1, that will be y equals to 1. Now, again, let's take the limit on both sides of the function as x approach positive infinity. Equals to limit as x approach positive infinity, x squared minus 2 divided by x squared plus 2. Now, if you directly plug infinity into x here, you get infinity squared over infinity squared. That's not the answer you want. So what we have to do is, let's try to divide the top and the bottom by x squared to get rid of this 2x squared, right? I mean the x squared here and here, right? So that see if you can go further from there. We keep the left side the same, right? Here, like that. Now, limit as x approach positive infinity, x squared minus 2 divided by x squared divided by, or divided by x squared plus 2 divided by x squared. Now, by doing this, I have not changed this fraction here at all, because this is the same as multiplying by x over 2. This is the same as multiplying by x squared over x squared, which is 1, right? A number multiplied by 1 is the same number. Okay, but in this case, what would this be? Now, x squared over x squared is 1 minus 2 over x squared. In this case here, x squared over x squared is 1 plus 2 over x squared. Okay, the left side is still the same. This will be limit as x approach positive infinity. That will become 1 minus 2 over x squared divided by 1 plus 2 over x squared. Now you can put infinity into x here. Let's see. One minus 2 over, right, infinity square here, divided by 1 plus 2 over infinity square here. Now notice that infinity square is a very, very large number. 2 over a very, very large number is close to 0. So we have 1 minus 0 here. And this will be 1 plus 0. So limit as x approach positive infinity, f at x equals to 1 over 1. 1 over 1 is 1. Here, equals to 1. Now, this form here is the same as this form here, right? So L is equal to 1 in example number 2. That means the horizontal asymptote here is equal to 1. Y equals to 1. So this is the same as this, right? So either way, it should work. Okay, let's look at example number 3. Let's say f at x is equal to x cubed plus 2x squared minus 3x divided by x cubed plus x squared. Now, again, right? The highest degree of power in the denominator or in the numerator is 3. And the highest degree of power in the denominator is also 3. Right? Then the horizontal asymptote will be the leading coefficient divided by the leading coefficient, which is 1 over 1. So y equals to 1 is the horizontal asymptote. Now y equals to 1 over 1. That is y equals to 1. Now, let's take the limit as x approach infinity on both sides of this function and see if we get the same answer. Limit as x approach infinity, right? Positive infinity. X cubed plus 2x squared minus 3x divided by x cubed plus x squared. Okay, of course, you cannot directly plug infinity into x here. Then you will get infinity over infinity. Infinity cube over infinity cube, like something like that. That's not the answer we want. So what we have to do is divide the top and the bottom by x cubed to get rid of the x cubed here. Then we can put in the infinity. Okay, let's see here. We keep the left side the same. Now limit as x approach infinity, divide the top function by x cubed and the bottom function by x cubed. Right? Again, I have not changed anything. I have not changed this function here. Now, what would that equal to? Limit as x approach infinity. Now, the top here, x cubed over x cubed is 1, plus 2x squared over x cubed is 2 over x, minus 3x over x cubed is 3 over x squared, divide by x cubed over x cubed is 1, plus x squared over x cubed is 1 over x. Okay, now you can put infinity with x here. Okay, limit as x approach infinity, f at x is equal to, now let's do this, right? 1 is not affected. Now if you put infinity into x here, 2 over a very, very large number is close to 0. Minus, now if you put infinity here, it's infinity squared. 3 over a very, very large number is close to 0. Divide by, yeah, 1 is not affected. Now 1 over infinity, right? That will be close to 0 as well. Okay, now here, the left side is the same. Limit as x approach positive infinity f at x is equal to, now this is just 1 over 1. 1 over 1 is 1. So that's equal to 1. Now, what does it mean? That means the horizontal asymptote is y equals to 1. So the answer here is the same as the answer using the rule. Okay. Now, let's look at example number 4. Let's say f at x is equal to 2x squared plus x minus 1 divided by x squared plus 2x. Okay, so the highest degree of power in the numerator is 2, right? The highest degree of power in the denominator is also 2. According to the rule, right? It is this situation here, okay? N equals to m. Then the horizontal asymptote is the leading coefficient divided by the leading coefficient. And in this case, it will be 2 over 1. So the horizontal asymptote y equals to 2 over 1, which is y equals to 2. Okay, now let's take the limit as x approach positive infinity on both sides of this function. Okay, now, of course, you cannot directly put infinity into x here because you will get infinity square over infinity square, something like that, which is what we don't want, okay? Okay, the best thing to do is divide the top and the bottom by x squared to get rid of the x squared here. And then we can see the left side is the same. Now, divide this by x squared, or divide by this divided by x squared. Right? So I have not changed the fraction here. Okay, so what's that equal to? Limit as x approach infinity. Now 2x squared over x squared is 2, plus x over x squared is 1 over x, minus 1 over x squared. Divide by, here x squared over x squared is 1, plus 2x over x squared is 2 over x. Now you can put infinity into x here. Now let's directly do this. The left side is still the same. Okay, so the 2 is not affected. Plus 1 over, now this is infinity now. 1 divided by infinity is close to 0. Minus 1 over infinity squared is close to 0. Divide by 1 is not affected. Plus 2 over infinity, which is close to 0. Okay. Limit as x approach infinity, f at x is equal to, now this is just 2 over 1. Now 2 over 1 is equal to 2. That means the horizontal asymptote for this function here is y equals to 2. And of course, the answer is the same as using the rule. Okay, let's try another example. Example number 5. Say f at x is equal to 3x squared plus 4x minus 5 divided by 2x squared plus x plus 1. Okay, using the rule, right? The highest degree of power in the numerator is 2. Also, the highest degree of power in the denominator is 2. So the horizontal asymptote will be 3 over 2. Okay, now let's take the limit as x approach positive infinity on both sides of the function and see if we can get to the same answer here. Now again, you cannot directly plug infinity into x here. what we have to do is divide the top and the bottom by x squared to get rid of the x squared here. Three x squared plus 4x minus 5 divided by x squared. Now all divided by this 2x squared plus x plus 1 all divided by x squared. Right? I have not changed the fraction here. Now, what is that equal to? The left side is still the same. Now limit as x approach infinity. Now 3x squared over x squared is 3 plus 4x over x squared is 4 over x minus 5 over x squared is 5 over x squared. All divided by, now 2x squared over x squared is 2 plus x over x squared is 1 over x plus 1 over x squared is 1 over x squared. Now you can plug infinity into x here. Let's directly evaluate this. Now 3 is not affected. Now plus 4 over, now this is infinity now. That will be close to 0. Minus 5 over infinity square close to 0. Divided by 2 is not affected. Plus 1 over infinity close to 0. Plus 1 over infinity square close to 0. Okay, so that is equal to 3 over 2. That means the horizontal asymptote for this function here is y equals 3 over 2. Y equals to 3 over 2. And of course, the answer I get with the limit, using the limit, is the same as the answer I get using the rule. Okay, let's try example number 6. Let's say f at x is equal to 7x to the 5th plus 3x to the 4th divided by 5x to the 5th minus 2x cubed. Now, using the rule, the highest degree of power in the numerator is the same as the highest degree of power in the denominator. That means the horizontal asymptote is equal to 7 over 5. Y equals to 7 over 5. Next, let's take the limit as x approach positive infinity on both sides of the function. See if I can get the same answer. Again, do not directly plug infinity into x here, because you will not get the answer you want. What we have to do is divide the top and the bottom by x to the 5th to get rid of the x to the 5th here. The left side is still the same. Now, 7x to the 5th minus or plus 3x to the 4th divided by x to the 5th. All divided by, now, 5x to the 5th minus 2x cubed divided by x to the 5th. Again, I have not changed this fraction here. Okay, what would that be? limit as x approach infinity. Now 7x to the 5th divided by x to the 5th is 7, plus 3x to the 4th divided by x to the 5th is 3 over x, all divided by, now 5x to the 5th divided by x to the 5th is 5, minus 2x cubed divided by x to the 5th is 2 over x squared. Now you can plug infinity into x here. Now let's evaluate this directly. Now 7 is not affected. 7 plus 3 over infinity is close to 0. Divide by 5 is not affected. Now 2 over infinity is close to 0. Or infinity square. Now that is equal to limit as x approach infinity. F at x is equal to, now this is equal to 7 over 5. What does that mean? That means the horizontal asymptote for this function here is y equals 7 over 5. Now again, the answer I get with the limit is the same as the answer I get with the rule. Okay. Let's look at the last example. Example 7. Let's say f at x is equal to square root of 4x squared plus 2, all divided by 3x plus 3. Now, let's look at this function here. If you look at the highest degree of power in the numerator, which is 2, and the highest degree of power in the denominator, which is 1, it looks like maybe it's higher at the top and lower at the bottom. But the case is that, right? There's a square root here. Once you take the square root into account, this will become x to the power 1. So in fact, the highest degree of power in the numerator is also 1. So we should have a horizontal asymptote. Okay, in this case, let's rewrite this function here first. So we have f at x equals to, now, square root of, here, this one we can see that as x squared times 4 plus 2 over x squared. We factor out the x squared here. Okay? Okay, now that is the same as here. Square root of x. We can break this down, right? Square root of x times square root of 4 plus 2 over x squared. Keep the denominator the same. Okay. Well, actually, square root of x squared is x, right? So what we can do is factor the x out in the denominator. So we have this. X times 3 plus 3 over x. Okay, so f at x is equal to here. Now this is x times square root of 4 plus 2 over x squared divided by x times 3 plus 3 over x. Okay, now x and x cancel out. All I have left is f at x equals to square root of 4 plus 2 over x squared divided by 3 plus 3 over x. Okay, now we simplify the function a little. Let's take the limit as x approach infinity on both sides of the function. And you can directly plug infinity into x here. Okay, let's evaluate this directly. Square root of, now 4 plus 2 over infinity square is close to 0. Now 3 plus 3 over infinity is close to 0. So what I have here is limit as x approach infinity f at x is equal to now square root of 4 divided by 3. Now, when you take the square root, right, you have a positive and negative value. So limit as x approach infinity f at x is equal to positive or negative 2, right, divided by 3. Okay, so what does that mean? That means the horizontal asymptote now in this case, I would say horizontal asymptotes. There are two horizontal asymptotes because of this signs here. Y equals to positive 2 over 3 and y equals to negative 2 over 3. Okay, that's the answer. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.